last presentation is by Chenko. He is a graduate student of ISTC. Yes. Are you ready? Okay, please.
Konnichiwa. My name is Jeremiah, and I will be talking about my research, which is development of hidden Markov model-based speech synthesis system for Chichewa language. I will talk about the motivation for my research before discussing Chichewa language, the justification for the proposed methods, the methodology used, the setup of my experiments, the results, and a discussion of future work. So Chichewa is a language spoken by more than 17 million people in Malawi, and that's not including people that speak the language in neighboring countries such as Tanzania, Zambia, Zimbabwe, Mozambique. For those that are not familiar with these countries, it's in southeastern Africa. Chichewa, right now, because it is more of a spoken language, not written, it faces threats from English, which is used for formal communication because it is easier to document. Also, in Malawi, adult illiteracy is still very high. The latest numbers point to between 65 and 73% of adults above 15 years of age can read and write, which means that the rest of them cannot read and write. Interestingly, Africa is going through a rise in mobile technology adoption, and this presents an opportunity to localize access of information in our native languages. And this is what motivated me to do this research. Because of these reasons, I proposed to come up with a natural-sounding speech synthesizer for Chichewa language, a prototype, of course. Okay, a little bit about Chichewa. The first thing that, the slide is a little not doing me justice here, but the first thing that I will talk about here is this verb, kala. The A is supposed to be at the end there. Anyway, this is a verb which means stay. And if I prefix it with this word ndi, which is a subject pronoun, I, and I can prefix it as well with this with this present continuous tense marker, am, and what I have is a phrase, I am staying, ndi kukhala. And if I add ku, which is preposition in, and Japan, which is a object noun, then I have a situation here where I've got my first, or at least I've taught you your first Chichewa sentence, which is ndi kukhala ku Japan, which translates to I am staying in Japan. So the first thing that we notice here is this feature in the language where we took the verb stem and we compounded it with affixes, in this case 2 prefixes, to come up with a phrase. And this characteristic is called agglutinative. And other languages like Turkish and also Japanese share the same characteristic. The next thing that you notice is the composition of the syllables here. The general rule is that you have got a consonant cluster, 2 or 3 consonants, and 1 to 3 consonants, and then followed by a vowel. And then you've got an optional literal an N sound that can come before this combination, and an optional vowel that can come after this combination. And this rule basically is what is used to come up with syllables in Chichewa. Now, if we remove the parts of speech that we don't really need to make sense of the sentence, then we have here subject, verb, and object, which is the sentence structure that Chichewa uses, which again is similar to that in Japanese. And the next thing that I want to talk about is the intonation. Chichewa's got 2 main tones, a high and a low. And the tones play certain roles in the language, such as marking tense as well as focus. And in this case, if I change the ku in Ndigukala, this tense marker, then I can change the tense of the whole sentence. At the moment, the ku is in its low, but if I make it high, to say Ndiku Kala, then I can change the entire sentence tense to read while I was staying in Japan. Ndiku Kala, I am staying, Ndiku Kala, while I was staying. So that's the intonation in Chichewa. Anyway, to summarize, Chichewa is an agglutinative language. Chichewa sounds are represented by 5 vowels and 18 consonants. It follows a subject-verb-object structure. Syllables have a CV canonical shape with optional N before it and an optional V after it. And it's got 2 main tones that are used to mark tense and focus. Now, we may or may not know that there are different types of achieving speech synthesis. The type that we've sort of converged to over the last few years is this method called unit selection, or a concatenative type that uses a lot of data to predict how speech should be pronounced at given any input. And this is what's used primarily in systems like Google Voice and Siri, etc., etc. However, in my research, and as I mentioned earlier, because of the lack of documentation of the language, I did not have enough or adequate speech corpus to carry out this type of synthesis. So we settled for a statistical approach which uses HMMs, and these were used because they present an exciting application to natural language processing because of their ability to solve problems in non-observable scenarios. There's a lot of work that's been done by Professor Tokuda for HMM-based speech synthesis here in Japan. And this is an example of a 3-state L to R HMM model. And basically what we have is the transition probabilities, the output probability distribution, and as well as the initial state probability. And so calculating this gives us a what is basically the role of the HMM in this case. And this HMM could be a word, or it could be a sequence of phonemes. And so given an observable state, i.e. speech that we can hear, we want to find out what it actually means, what the absolute value phonetically of that speech is, and that's the role of HMMs. Because of time, I cannot go into details to explain exactly the problems and the decoding and the algorithms. So, with that said, I went into the studio and recorded some speech corpus using these settings. A total of 300 phrases is what I recorded, short phrases so that we do not confuse or do not create a complicated model, but just short utterances that had a total running time of 14 minutes. And this is an example of the type of sentences that I collected. Mundionetse timetable, show me the timetable. Ndikufuna kugonela pansi, I would like to sleep on the ground. Ndikupita ku Blantyre, I am going to Blantyre. Blantyre is the city that I come from in Malawi. So anyway, this gives you an idea. The next thing was to come up with phonetic rules for Chichewa language. At the time of this research, there were no phonetic rules, the International Phonetic Alphabet for Chichewa language. So I had to manually, with help from a colleague, of course, I had to manually come up with the rules of how phonemes are constructed, just from listening to each and every sound that was available in the corpus. The reason for that is so that I could come up with this alignment of the utterance, the wave file, the sound, as well as it's breaking it down into its individual phones, as you can see below here, as well as the boundaries where those phones appear. And this is an example, Dziko lanu ndilo kongola, which means your country is beautiful. And then the experiment setup is, I used mainly the HTS system that I talked before by Professor Tokuda. And there are some other dependencies that were used to, for instance, to come up with these labels. We used HTK, which was used for training an acoustic model. That gave us the labels that were needed. The speech database is obviously the corpus that I recorded, and HTS provided some tools for extracting the excitation and spectral parameters, as well as obviously training the HMMs. And the text analysis part in the synthesis system was done by Festival, which is a famous system, and it's got a lot of tools for natural language processing. And then there's SPTK, as well as the HTS engine API that was used to come up with, to actually generate the excitation and the synthesis to produce synthesized speech. Now, HTS, the setup requires that they be information showing phonetic and prosodic features of the language. The phonetic part is what we were able to achieve by coming up with the phonetic rules and using the acoustic model to come up with forced alignment. However, the prosodic information, as you can see with the previous information, description of the language, is very difficult to extract. And this is an example of how the full context HMM label looks like in an HTS-based speech synthesis system. And so what we did with coming up with the prosodic information is we actually borrowed some information from the English language, which has got a lot of resources, been well researched. And the results are like this. The top is the synthesized speech, Mundionetse timetable, show me the timetable, and the bottom is the original speech. So this is a comparison of the decibel levels. And that is a comparison of the spectrogram, the energy that's in the synthesized speech versus the original speech. And then I carried out a subjective analysis where I asked 10 native speakers of Chichewa to listen to some randomly selected utterances and tell me if they understood and tell me what they understood the meaning to be. And what we found is that where there was between 17 and 20 phones in the utterance, the accuracy was the highest. Otherwise, the accuracy was, as you can see, not very high. And so what I'll do is I'll play a sample of a synthesized speech.
Muna wakupera ntchito kuti munalandirapo magazi.
And I'll contrast that so that you can judge it based on the original recorded speech.
Amuna anu akugwira ntchito kuti. Munalandira magazi.
So I'll play that again.
Amuna anu akugwira ntchito kuti. Munalandira magazi.
Okay, as you can hear, I sound a little bit like an old man in the synthesized voice. But anyway, so as I mentioned earlier, coming up with prosodic rules for a language is quite a challenging task. It requires not only computational skills, but obviously linguistic skills. And so it turns out that for under-resourced languages like Chichewa, borrowing prosodic information from other similar languages in a technique called transfer machine learning, is a better solution for HMM-based speech synthesis. And so future works could actually look into, we borrowed prosodic features from English, but maybe we can borrow prosodic features from a similar language to Chichewa that's more resourced. Maybe Swahili, we could look into that in the future. And then applications for Chichewa text-to-speech system lie in an embedded environment, and limited domain will be more effective. So because of the low corpus or the limited corpus, having a speech system, TTS, Chichewa text-to-speech system in limited domain, say maybe in banking or telephony or education, would probably be more effective than having a general TTS system. Thank you.
Thank you. So it's a time for comment and question. At first I asked the referees.
So I'm not so familiar with this field. So I'd like to ask you very basic questions. What is the most significant difference of your system and other languages, such as English and Japanese?
Okay. Between the two languages or between the speech synthesizer?
Two languages.
Oh, two languages, right. Okay, so the first difference that I could give between a language like Chichewa and perhaps a language like, with my little knowledge of a language like Japanese, is obviously the syllable construction. In Chichewa, as I earlier alluded to, the consonants or the phones that are used to come up with a syllable can be a little bit complicated. So, for instance, the word ntoji is spelled N-T-H-O. So it's got three consonants before a vowel. And sometimes for speakers of a language like maybe Japanese or English, to come up with that pronunciation of nto can be a little difficult. The other thing that we found is that there are some special pronunciation or sounds that are only found in a Bantu language like Chichewa. For instance, the nasal sound ng, which is N''G, and it is a consonant sound that if you concatenate it with a vowel, you can have the word ngona, which means crocodile. And basically what that sound N''G is, from what I understand, is not found in non-Bantu languages. So it's native to Chichewa.
Okay, thank you. And I'd like to ask you another question about the scalability of your proposals. So can we use your system to use much more number of utterances, such as you said, use the 300. So can we use more than 10,000 with your systems?
That's a good question. With HTS, with the work that Professor Tokuda has done, One of the advantages is that it doesn't require a large, well, obviously large is a subjective term, but it doesn't require too much of a corpus. So an adequate amount would be anywhere between 1,000 and 3,000 utterances. Actually, if you go on the HTS, you can download the demo, which provides an English training data of 1,200 sentences, and that training data produces pretty good, pretty accurate results. So the advantage of HTS is maybe with 1,000, maybe with 1,500 utterances, we can come up with a better voice model.
Thank you. Thank you.
In your presentation, the motivation of your research is this was described very clearly. So I totally understand the purpose of the research. But I have a few concerns about the model training of HMM. Generally speaking, when we train a generative model such as HMMs, we need a lot of training data. But you only prepared 300 sentences for training corpus. But I think there is a problem such as overfitting. But did you apply some pre-processing or some schemes to avoid the overfitting in your framework?
Thank you for your question. Firstly, I will say that yes, the utterances were probably lower than what would be ideal for a good system, because we wanted to prove a concept, to come up with a prototype, and secondly, to answer your question of overfitting, we from the documentation that I read from HTS, the clustering algorithm that they use, I wish I could have it close to me, but the clustering algorithm that they use provides functionality to be able to solve that problem of overfitting within the HTS system.
So the pre-processing or some schemes are included in the HTS?
That's correct. There's some algorithms that are used and some tools that are used in HTS that provide that solution.
Okay, thank you. And I think your research has the potential to attract many researchers and other Chichewa language speakers all over the world. So, do you have any plan to extend your research in future?
Thank you for your good question. Yes, I have plans. Obviously, there's a lot of things that I had to learn because of being the first to do a Chichewa language synthesizer. And so having overcome some of the original challenges, I think I am in a good position to start really looking at more effective methods to enhance the research in the near future. Yeah.
Very good. Thank you.
Okay, it's a time for inviting the comment question from the floor. Is there any? No question or comment? How about the time sensor? No. So, thank you, Jenny. It's a time for the finishing this session. Thank you very much.